Hello viewers, you're welcome to my YouTube video. Today I'll continue with the solution to the West African Examination Council 2023 past question, okay? And I'll be solving the second question. And before I do that, I'll read out the question. The A part of the question: in a football match, the tickets for children and adults were sold at 3D and 5D. That's the cost of the ticket for children is 3D each, and for adults it's 5D each, respectively. If 400 people attended a football match and 1,700D was collected in ticket sales, how many tickets were sold to adults? Okay, so this was the amount made by selling 400 tickets, both from children and from adults. Okay, they made 1,700D. The B part of the question said Mr. Johnson sold 250 tickets, still referring to the same tickets. If 175 of the tickets were for adults, how much sales did he make altogether? Now to the A part of the question. To figure this out, I will say let number of tickets sold be as follows. Okay, X for children and then Y for adults. Now if that be the case, I can say X plus Y, that is the total number of children and adults that attended the competition. How many are they? 400. Okay, 400, that's for children and adults. If you sum up their population, they are 400 in number. So I'll christen this equation 1. And then the B part, or rather the second equation, can be gotten from the costs. The cost of the ticket for children is 3D per child and 5D per adult. Okay, so I'll have 3 times X. 3 times X means 3D multiplied by the total number of children plus 5 times the total number of adults, Y, and that will give me the total number of money collected at the football competition. So D, or rather 1,700D, was a profit. So they made this by selling 3x of tickets for children and 5y of tickets for adults. So I need to find X and Y. Okay, I'll christen this equation 2. Solve equation 1 and 2 simultaneously. Now I presume you are familiar with the methods used in solving simultaneous equation. Analytically, the two methods usually employed in solving simultaneous equation is the method 1 is the elimination method, and the other one is the substitution method. So I'm going to take you through both, but let me show you how to solve this simultaneous equation by elimination method. Okay, so to solve this, first I will multiply equation 1 by 3. The reason is because I want to eliminate X. So I have 3X here. So if I must eliminate X, this X must be 3x2, so that 3x minus 3x will be 0. Okay, so 3 times x will be 3x plus 3 times y is 3y equals 400 times 3 is 1,200. So I'm done with equation 1, and what I did to equation 1 is to multiply it by 3. Now equation 2, I'll just multiply it by 1 because I don't need to change the coefficient of this variable, because I multiplied equation 1 by 3 because the coefficient of x in 2 is 3. So I will replicate the content of 2 by just multiplying each and every one of the terms by 1. So I have 3x plus 5y equals 1,700. Now I need to subtract this equation just based on what I explained earlier, because I wanted to eliminate x. So to eliminate x, the coefficient of x must be the same. If I want to eliminate y, the coefficient of y must be same. So I felt eliminating x is simpler for me. So 3x minus 3x is 0. Now I have plus 3y minus plus 5y. So minus times plus is minus. So I have plus 3 minus 5, which is the same thing as minus 2y, equals 1,200 minus 1,700 is minus 500. I'm looking for y, so I'll divide through by y. Therefore, y will be equal to minus 500 divided by minus 2. Y will now be equal to 250. Therefore, 250 tickets were sold to adults. Is that okay? 250 tickets. Now, I want to get this same value of y using another method, which is the substitution method. Method 2 is substitution method. So if I want to solve this problem by substitution method, I need to make one of the variables, either x or y, subject of the formula in one of the equation, and I'll substitute it in the other. Looking at equation 1 and 2, you agree with me that equation 1 looks simpler because the coefficients of x and y in equation 1, the coefficients are what? 1 and 1 respectively. So it's easier to make one of the variables subject of formula. So I will make x subject of the formula. From equation 1, x will now be equal to 400. I will take plus y to the other side of the equation, or I will subtract plus y from both sides. So plus y minus y is 0, 400 minus y. So I'll have minus y. I'll christen this equation 3. Okay? I'll christen this equation 3. Now I need to substitute equation 3 into 2. I know some of you will be wondering, why didn't I substitute it into 1? Why 2? I can't substitute it into 1 because I got 3 from 1. So if I substitute 3 in 1, I'll get back the original equation. So I'm not making any progress, right? So to solve this problem, if you make one of the variables subject of the formula in one of the equation, you are substituting that new equation into the second equation. So I have to substitute equation 3 into 2. Now 3 is 3x plus 5y equals 1700. So I'll write 3, I'll open a bracket, x will be replaced by 400 minus y. So I'll write 400 minus y. I'll close up the bracket, then I have plus. So I'll write plus 5y equals 1700. Now I will expand this bracket. 3 times 400 is 1200 minus 3 times y is 3y plus 5y equals 1700. Now I have 1200 minus 3y plus 5y is plus 2y equals 1700. Remember, I'm looking for y. So I'll make 2y subject of formula first before making y subject of the formula. So if I have 2y equals, at the right hand side of the equation I have 1700. If I subtract 1200 from both sides of the equation, 1200 minus 1200, the left hand side of the equation will be left with 2y. And then the right hand side will be minus 1200. So I subtracted 1200 from the left hand side. I'll do same to the right hand side. 2y will now be equal to 500. So I'm looking for y. I will make y subject of the formula by dividing both sides of the equation by 2. If I do that, the left hand side will be y equals 500 divided by 2. Therefore, y equals 250. So you can see 250 tickets were sold to adults. So y is 250. Is that okay? So that's the solution to the A part of the question. Now to the B part, Mr. Johnson sold 250 tickets. If 175 of the tickets were for adults, how much sales did he make altogether? To figure out this problem, I need to say let number of tickets sold by Mr. Johnson be equal to 250. We've been told in the question, right? That's in the second part of the question. 250 tickets were sold by Mr. Johnson, okay? Now let number of tickets sold be as follows. Adults, 175 tickets were sold to adults, okay? It's been stated in the question. Now for children, it will be equal to 250, which is the total number of tickets sold, minus 175. The difference between 250 and 175 is 75. Is that okay? 75. Now, since 75 is the amount of tickets sold to children, now the work is easier. Recall from the previous slide that the following from the previous slide, that from question 2a, adult ticket costs 5D. The cost of a single ticket being sold to an adult is 5D, and children tickets, that's the one sold to children, cost 3D. Now, since we have 175 adults and 75 children, the total number of tickets sold by Mr. Johnson we can calculate that using the following method. Okay, adults will be 5 because each ticket for an adult costs 5D, so it will be 5 times the total number of adults, 175, which boils down to 875D. For children, each ticket costs 3D, so it will be 3 times 75. Okay, 3 times 75 will be equal to 225D. Therefore, the total sales made by Mr. Johnson to adults and to children equals the summation of 875D plus 225D, and this boils down to 1100D. So the total amount of the total sales made by Mr. Johnson in the second part of the question is equal to 1100D. Thank you for watching my YouTube video. Do subscribe if you've not. The name is Victor in STEM. And if you have any comments, you can drop it at the comment section. See you the next time as I'll be solving other problems from the same past question. Bye bye.